Let's consider this first question here. We want to know how much weight on average do students living on campus gain during their freshman year? So this value that we're trying to find is a value that we call mu, which would be the mean weight gain of all freshman students. And this value is typically unknown. The reason being that it's very difficult for us to survey the entire population. So if we're looking at the population, which would be the weight gain of every single freshman student, let's just limit it to North America. This would be a very, very large number. So I don't know what N is. N is just a really big number, but we can think of X as the weight gain for an individual freshman student. So if this blue circle represents the population, then this circle, I want you to just imagine that it consists of a whole bunch of X values where each X represents the weight gain for a particular freshman student. So let's suppose that student X sub 1 gained 3 pounds. Let's say that student 2 gained 2 pounds, and then let's say student 3 gained, I'm making up some data here. Let's say the student gained 10 pounds. And then another student in our population, maybe they also gained 3 pounds. Let's suppose the student gained, oh, I don't know, 2.5 pounds. And I'm just going to list a few more here, but I hope that you guys can see that it would be impossible for me to list the weight gain for every single freshman student in the population. But let's suppose that this circle contained all those values all the way up to, I'll say, X sub n, where X sub n is the last student in the population. Okay, so what is a sampling distribution? A sampling distribution is when we take samples from the population and then we take a look at our sample data and we plot it on a distribution. So again, very hard for me to survey data and get data for the whole population, but I could definitely take a sample. So let's call this sample one. So I take a sample and let's suppose that that sample consists of 125 of these values. So 125 freshman students. And then we find out that the average weight gain for those 125 students, let's say it's 2.7 pounds, okay? Then we can plot that on the distribution on the right. So I can plot, I'll call this X sub 1. I can plot X sub 1 somewhere near here, okay? And then I repeat this process. So I go and I take, okay, well, what happens if I take another sample from the population? Let's call this sample two, right? But the key here is that I'm taking a random sample of the same size. So another 125 students. So this is like me repeating the freshman 15 study. I take that study and I just repeat it with another random sample of 125 freshman students. And let's suppose at this time, the average of those 125 students, let's say that's only 3 pounds, okay? So then I mark X sub 2 on the distribution on the right. And the idea of a sampling distribution is this idea that we keep repeating this process. I take as many samples of the same size from the population and I figure out what the mean value is. So again, I can do this an infinite, well, I wouldn't say an infinite number of times, but if n was a finite value, there is a finite number of samples that I can take of size 125. So I'm not going to do this forever, but I want you to imagine I take lots and lots of samples from the population, all of the same size. And every time I do that, I get an X bar value. And that X bar value could be the same as another sample's X bar value, or it could be completely different. But the whole idea behind a sampling distribution when we're looking at sample means is when we plot all of these X bar values, what ends up happening, so let me just draw a couple of examples of what that plot would look like. Okay, it turns out that let me just draw a few more X bar values. It turns out that this, so what I have on the right hand side here is this sampling distribution. So the sampling distribution, and this is a sampling distribution of sample means, so of X bar values. It turns out that it is also normally distributed. So this is a very interesting concept. When I take samples of the same size from the population and calculate the sample mean, and I repeat this process many, many times and plot all those sample mean values, the distribution of those sample mean values is normally distributed. And so we know certain characteristics about normal distributions. We know that we can find the average of all those sample means to be at the center of this distribution. So I can say that the mean, you can think of it as an average, the mean of all of these X bar values, so the mean of all your sample means, it turns out that this value targets, okay, the population mean. So remember before we said that in question one, we want to know what the average weight gain is for all freshman students. But because we can't survey the entire population, this mu value, this mean value is unknown. However, if I take lots of samples from the population, I can estimate what this value is by taking the average of all of those sample mean values. And so it turns out that the mean of all the sample means, and the notation that we use for this is mu sub x bar, it gets really, really close to or equal to the population mean. And again, this value is typically unknown. So this is very interesting because it tells us that we can estimate for unknown values by creating sampling distributions, which just means takes lots of samples of the same size from the population and then calculate the average of all those sample mean values. It gives us a very good estimation of what the population value is. Before we leave this video, though, I do want us to consider the second question, which is different from the first question. The second question is asking, do students living on campus actually gain 15 pounds? And so this is something that we want to either prove or you could disprove this. So this is something we'll talk about in later chapters when we talk about hypothesis testing. But the sampling distribution that you see in this section comes into play when we start talking about hypothesis tests. So I just want you to keep that in mind when we get to hypothesis testing.